Okay, factors of positive 20 that add up to positive 9 are positive 5 and positive 4. So this is x plus 5 times x plus 4. Here we have the difference of two squares. This first item is 7x quantity squared, and the second item is 9y quantity squared. So you're always going to get conjugate pairs. The first item plus the second item times the first item minus the second item. Okay, there's a lot of ways to do this. This might be 8 and 1, but I'm going to try 4 and 2 first, and I might have to go back and go to 8 and 1. And this could be 15 and 1, but I'm going to try 5 and 3 first. But I do know that both of them have to be negative. So if I put the 5 here and the 3 here, what that does is on the outside it gives me negative 20. On the inside it gives me negative 6. Negative 20 plus negative 6 is negative 26. So that works. And there's, you kind of have to do those by trial and error if you don't see it right away. If you recognize that the first item and the last item are positive perfect squares, you might have a perfect square. You always put the square root of this first, this sign next, and the square root of that next. This might be the answer, but you got to check the middle term. You do it by multiplying these two things and doubling. This times this is negative 12x. When you double, you do get this, so that is the answer. Okay, you have something times something plus something times something. It's like as if you had like AB plus CB. This something is the common term, and if you factor it out, you're going to be left with A plus C. Well, the same thing. The 3x minus 7 are like terms, so we factor that out, 3x minus 7, and then we have this plus that. So 2x plus 3 plus x plus 2. And that simplifies to 3x plus 5. So we have 3x minus 7 times 3x plus 5. Okay, here we have a GCF. So I'm going to pull out a 5 to start because I can. And that makes this problem a lot easier. Now I'm looking for factors of positive 20 that add up to positive 9. And again, it's 5 and 4. So we have 5, x plus 5, and x plus 4. Here we have a recurring element, so I can call that something like a equals 2x minus 3y. So what I have is a squared plus 3a minus 28. And I'm looking for factors of negative 28 that add up to positive 3. And that's going to be positive 7 and negative 4. But now remember, there's no a, so now I resubstitute that for this for a. So I'm going to end up with 2x minus 3y plus the 7, 2x minus 3y minus the 4. Here I have 4 terms, so I'm going to try to see if I can factor this by grouping. I'll group these two things together here as if they're a separate problem and pull out the 4a. And that leaves me with 2c plus 5d. So I'm going to leave a big space and put 2c plus 5d down again, because whatever I leave behind here, I have to leave behind here. Then I'll think about what I have to put here so that when I distribute it, I get back to those. And it looks like a negative 3b. And that works. So my final answer is 2c plus 5d times 4a minus 3b. Here I have the difference of two cubes. The cube root of this entire thing is 3x. The cube root of that is 4y. So you always end up with a binomial times a trinomial. Your binomial are your cube root items, and your trinomial, you go square, product, square. So the square of this is 9x squared. The product of the two things is 12xy. And the square of the last item is 16y squared. And then you use SOAP. Same, opposite, always positive. And that's it. Okay, here I'm looking for factors of 28 that add up to negative 13. So like negative 1 and negative 28, but that adds up to negative 29, so that's not it. Negative 2 and negative 14, this adds up to negative 16, so that's not it. 3 doesn't go in, but 4 does. Negative 4 and negative 7, this adds up to negative 11. And then that's it. Those are all of the factors, and none of them add up to 13. So this is prime. Okay, here I'm looking for factors of negative 60 that add up to positive 4. And remember that there's one's positive, one's negative, so I'm actually subtracting. So let's see, 10 and 6, positive 10 and negative 6. These multiply to negative 60 but add up to positive 4. Here I have the sum of two cubes. The first item is 2x cubed, and the second item is 5y cubed. So you're going to end up with a binomial times a trinomial. Your binomial are your cube root items. The 5x is 2x and 5y, and the trinomial is going to go square, product, square. So the square of the first is 4x squared, the product is 10xy, and the square of 5y is 25y squared. And then we're going to use SOAP. Same, opposite, always positive. More than one way to do this. This could be 6 and 1, but I'm going to try 3 and 2 first, and I might have to go back and change it. Again, this could be 6 and 1, but I'll try 3 and 2. I don't want to put the 2 here because that would create a GCF, and I know there's no GCF. So I'll try the 3 here and the 2 here. I'll put the negative here to give me negative 9 on the outside, and positive 2 here to give me a positive 4 on the inside. Negative 9 and positive 4 add up to negative 5, and these add up, multiply to negative 6. So that's it. Okay, this looks like a tough problem, but there's a GCF, so let's do that first. Now I'm looking for factors of 12 that add up to positive 8, so positive 6 and positive 2. So we're done. All right, these are factors that multiply, and it's already at 0, so the answer is positive 7 and negative 2. This is going to be positive 1 over 3 and negative 5 over 2. Now this 7 does not contribute to the solution, so our answer is positive 5 and negative 4/3. This 8 does not contribute to the solution, but this x does. So this x gives us a 0 and positive 2. Here I have to factor first. It's already set to 0, so I just factor. So this gives me plus 6 and negative 5. So this gives us a negative 6 for a solution and positive 5 for a solution. For number 20, first let's factor the GCF, which is x. And that leaves us behind an x plus 7. So this gives us a 0. This gives us a negative 7. Now this problem is not set equal to 0, so that's the first thing I need to do. I'm going to FOIL this out. First is x squared, outer is negative 5x, inner is positive 2x, last is negative 10 equals 18. And then I'll combine like terms. Negative 5 and positive 2 is negative 3x, and then I'll bring this over. Negative 10 minus 18 is negative 28. So I'm factoring this to get to negative 3, so negative 7 and positive 4. So I have x minus 7 and x plus 4 equals 0. So this gives us a positive 7 and a negative 4. Just like this problem, it's not set equal to 0, so I need to set it equal to 0. So I'm going to FOIL this and then bring these over. So when I FOIL, my first is x squared, the outer is negative 1x, the inner is positive 5x, the last is negative 5. So we have x squared plus 4x minus 5. I'll bring this over. 4 minus 1 is a positive 3. And I'll bring this over. Negative 5 minus 13 is negative 18 equals 0. So I'm looking for factors of negative 18 that add up to positive 3. So x plus 6 and x minus 3. These multiply to negative 18 but add up to positive 3. So this gives us a negative 6, this gives us a positive 3. Okay, I'm going to cancel an x from the top and bottom. So that becomes a 2 and that goes away. And then I'll divide by 7. That 7 goes into that 5 times, into this twice. So my final answer is 2x squared over 5. Here I'm going to factor out a 5. And we're left with 2x minus 3. Here, I'm going to factor out a 4. And I'm left with 3 minus 2x. These are opposites, backward around a negative sign. And opposites can be canceled as long as you pop on a negative. So this answer is negative 5 over 4. I'm going to factor this as x plus 5, x plus 2. And I'm going to factor this as x plus 2, x plus 3. And these cancel. So you're left with x plus 5 over x plus 3. I'm going to factor this by taking out the GCF, which is 3x. And we're left with x plus 2. I'll factor the bottom by taking out the GCF of 2. We're left with x plus 2. And so these cancel, and our final answer is 3x over 2. Okay, for number 27, it already has a common denominator, so I just got to subtract the numerators. Be careful, though, because the second numerator has 2 terms, so this negative is going to distribute. So you're going to have 8x minus 3x plus 2, not minus 2, all over 7. 8 minus 3 is 5, so 5x plus 2 over 7. Okay, the LCD between these is 15. So I'm going to make a 15. That means that I have to multiply this one by 3 to get to 15. So I multiply by 3 and I get 12x. I have to multiply this one by 5. So I multiply this one by 5 on the top and we distribute the 5 and I get 10x plus 15. So then when I combine these, I now have common denominators, so I add the tops and I get 22x plus 15 all over 15. Don't try to cancel those 15s because there's no 15 there to cancel. Okay, I can make this denominator look like this by factoring out a negative, and that negative I can put right here. So what I can do is have like 7 over 5x minus 1 minus 4 over 5x minus 1. 7 minus 4 is 3 over the common denominator, 5x minus 1. These denominators don't have anything in common, so my LCD is the product of the two, x plus 5 times x minus 3. So I'll make the first fraction 2x over x plus 5 plus 3 over x minus 3. Now, to make this look like this, I have to multiply by x minus 3. So I have to do that to the top as well. To make this look like this, I have to multiply by x plus 5. So I have to do that to the top as well. And then I'm going to distribute this and get 2x squared minus 6x. I'll take the positive 3 and distribute it and get plus 3x plus 15 all over that common denominator. So we're going to end up, when I combine like terms, with 2x squared minus 3x plus 15 all over x plus 5, x minus 3. Now, you have to decide if this is a reduced fraction, so you got to try and factor the top to see if anything can cancel. But because this is plus, I know my factors, inner and outer, have to add up to 3. There's no way I'm going to add up two things to just a small number like 3. So this is prime and cannot be factored, so this is a simplified fraction. Okay, when we're multiplying, I'm going to factor before I do anything, so I'll take out a 3 out of the top, and we'll have 2x minus 3 over 10 times 5 over, I'll take a 9 out, and we'll have 2x minus 3. So then I can start canceling. These 2x minus 3's cancel. 5 goes into 5 once, but into 10 twice. And 3 goes into 3 once, but into 9 3 times. So when I multiply across the top, I just get 1. And when I multiply across the top, I got 2 times 3, which is 6. When we're dividing, we're going to change this to a multiplication by flipping this upside down. But I'm going to factor everything while I'm at it. So I'll factor this and get x plus 5 times x plus 3. I'll factor this by taking out a 15. And I have x plus 4. And I'll change this to a multiplication by flipping this upside down. So the x plus 3 goes on the bottom, and I'll put the top, I'll factor out a 5 and get x plus 4. So now I can start canceling. These x plus 4's cancel, these x plus 3's cancel, and 5 goes into 5 once, but into 15 3 times. So we multiply across the top and get x plus 5, and we multiply across the bottom and just get 3. Okay, if you have only just one term in the top and bottom, just take the top, 4x over 7, and change this to a multiplication by flipping the second one upside down. So this is 21 over 8x squared. And then I'm going to start canceling. 7 goes into 7 once, into 21 3 times. 4 goes into 4 once, into 8 twice. And this, one of these x's cancels with one of those, making it a 1, x to the 1. And so the only thing left in the numerator is a 3. And in the denominator, we have a 2x. We have this 2 and this x. If you have multiple terms in either the numerator or the denominator, figure out what the LCD is first. So xy and xy, our LCD is xy. And then take that and multiply by each one of the factors. So I have 8x times the LCD of xy minus the LCD of xy times 12 over y over 4 over xy times that xy. So I took this xy and multiplied by each of those things. And then I cancel. This x cancels there, this y cancels there, and that xy cancels. So you end up with 8y minus 12x over 4. But this is not a simplified fraction because I have 3 terms, 1, 2, 3, and they're all divisible by 4. So this becomes 1, cancels and becomes a 2, and becomes a 3. So the final answer is 2y minus 3x. And don't put it over 1 because that's an unsimplified fraction. Okay, we're only looking at what can make the denominator 0 because then there'll be undefined fractions. So x cannot be equal to positive 3 or negative 2 over 5. This does not make a restriction because 4 cannot be equal to 0. There's no x there. Before we can figure out this one, we have to factor everything. So I'll take an x out of here. This is an x plus 7, x minus 5. So x cannot be equal to 0 from this, negative 7 from this, and a positive 5 from this. There's a 0 here, but we already have that. There's a negative 7 here, but we already had that. Okay, the first thing we're going to do is identify the LCD. There's only one denominator, so the LCD is x. That tells us that x cannot be equal to 0. Then I'm going to take in this x and I'm going to multiply by this, this, and this. When I multiply by this, I get x squared. When I multiply by the middle fraction, I get 16. And when I multiply by the 6, I get 6x. This is a quadratic equation, so I'll bring this over and have x squared minus 6x minus 16 equals 0. I'll factor with negative 8 and positive 2. So this tells us that x is equal to positive 8 and negative 2. Then we got to go back and make sure that neither of these values were restricted, and they're not, so that's the answer. 8 and negative 2. For this one, we got to make sure to factor everything. This can't factor, that can't factor, but this is the difference of two squares. So x plus 3, x minus 3. So the LCD is that. And then x cannot be equal to plus or minus 3. Okay, now I'm going to take this numerator, the x, and I'm going to multiply that by what's missing from the denominator, this x plus 3. And then I'll take this plus 4 in the numerator, and I'll multiply this by what's missing from the denominator, this x minus 3. And then I'll take this numerator, the 18, and I'll multiply by what's missing from the denominator, but nothing's missing. So I don't multiply this by anything. So now I'll take this x and distribute it, and I'll get x squared plus 3x. I'll take the positive 4 and distribute that, and get plus 4x minus 12 equals 18. Combining like terms, we got 7x, and then bringing the 18 over, negative 12 minus 18 is negative 30. So now I'll factor. Factors of negative 30 that add up to positive 7 are positive 10 and negative 3. So this gives us x is equal to negative 10 and positive 3. But the restriction was x cannot be equal to positive or negative 3. So this has got to be thrown out. So the answer is just negative 10. That's left over. Okay, this can't be factored, that can't be factored, but this is the difference of two squares, so we factor it like this. And so the LCD is that. And this tells us that x cannot be equal to plus or minus 2. Negative 2 from this and positive 2 from this. So now, I'll take this numerator, the x, and I'm going to multiply that by what's missing from the denominator, the x minus 2. And then I have equals 1, and I'll multiply this by what's missing from the denominator, the x plus 2. And then I have the plus 8, and I'll multiply this by what's missing from the denominator, and nothing's missing, so this doesn't get multiplied by anything. Now I'll take this x and distribute it, and we'll get x squared minus 2x. I'll take this 1 and distribute it, and get x plus 2, and then I have plus 8. So this is a quadratic. I'll bring this x over, and I have x squared. Negative 2 minus 1 is negative 3x, and this is a positive 10 that I got to bring over, and we'll get negative 10 over here. Now it's equal to 0. So I'll factor this as x minus 5, x plus 2 equals 0. So x must be equal to positive 5 and negative 2. But negative 2 was a restricted domain value, so this has got to be thrown out. So the only answer is positive 5. Okay, 3x plus 1 and x have nothing in common. So the LCD is the product of those. So x cannot be equal to 0 from this and negative 1/3 from that. So I'll take the numerator of the 2 and I'll multiply that by what's missing from the denominator, which is x. Then I'll take the plus 6x and I'll multiply that by what's missing from the denominator, which again is x. And then I'll take the equals 1 in the numerator and I'll multiply that by what's missing from the denominator, which is 3x plus 1. So this is 2x plus 6x squared equals, and I'll distribute the 1 and get 3x plus 1. So I have 6x squared, and now I'm going to bring this 3x over to the left, so I have 2x minus 3x is negative 1x, and then I'll bring the 1 over to the left, and that'll become a negative 1 over there. Now it's equal to 0. So we have 3x and 2x. Let's see, I'll put a negative 1 and a positive 1 here. That's because now I have negative 3 on the outside and positive 2 on the inside. Negative 3 plus 2 is equal to negative 1. So this tells us that x is equal to negative 1/3 and positive 1/2. But the restricted domain values, x is not allowed to be negative 1/3. So this has to be thrown out. So x is only equal to this 1/2. Hello. Hi. All right, 72 can be written as 36 times 2. So I'm going to rewrite that as 36 times 2, because 36 is a perfect square. And x to the 9 I can rewrite as x to the 8 times x. And then I can take out 36 by square rooting it and get 6. And take out x to the 8 and we'll get x to the 4, because 8 divided by 2 is 4. So this stuff is on the outside. And then we have the square root of the stuff that couldn't come out, the 2 and the x on the inside. Okay, here these are conjugate pairs, a plus and a minus with the same thing. So remember, when you have conjugate pairs, a plus b times a minus b, you always end up with the first item squared minus the second item squared. So when I square this and get 4, and I square this and get 5, and that ends up with a 20. Minus the square of this is 9. So this turns out to be 11. For this, you rationalize the denominator by multiplying by root 6 on the top and bottom, and we end up with 8 root 6 over 6, and then we cancel. 2 goes into this 3 times and into this 4 times, so we end up with 4 root 6 over 3. Okay, so in order to rationalize this, we have to multiply by the conjugate pair. So we'll just do the same thing, but put a plus in the middle. And you have to, if you do that to the bottom, you have to do that to the top. On the top, that 4 distributes, and you get 4 root 5 plus 4 root 3. On the bottom, these are the difference of 2 squares. So it's the first item squared minus the second item squared. This squared is 5, minus the next thing is 3. So this becomes over 2. And this is a reducible fraction. 2 goes into this once, into this twice, into this twice. It's over 1, so we don't write the denominator. So the answer is 2 root 5 plus 2 root 3. You could multiply 6 times 9 to get 54, but instead what I'm going to do is I'm going to have, this is the cube root of 6 times 3 times 2, which is 6, and 9 is 3 times 3. And all of this comes out as a single 3, because 3 factors come out as 1 factor. 3 to the 3 becomes 3 to the 1 when we take it out. So our final answer is the 3 that came out times the cube root of the 2. Okay, now I could multiply by the cube root of 4 on the top and bottom, but instead I think it might be easier to write 4 as 2 squared. That means now I can see I only have to multiply by the cube root of a single 2. It makes simplification easier. On the bottom, I have the cube root of 2 squared times 2 is 2 cubed, so the bottom just becomes 2. And in the top, we have 6 times the cube root of 2. And finally, 2 goes into 2 once, into this 3 times, so we end up with 3 cube root 2. You could multiply these together to get 50, and there's nothing wrong with that, but I'm instead going to do this. 10 is 2 times 5 times this 5, and these 2 will come out as 1, so I'll end up with 5 root 2. You could have multiplied this to 50 and then factored the 50. I just factored before I multiplied. For number 52, to rationalize the denominator, we're going to multiply by root 3 on the top and bottom, and we'll get 12 root 3 over 3, and 3 goes into 3 once and into 12 4 times, so we end up with 4 root 3. Okay, 1 root 7 minus 4 root 7, these are like terms. 1 minus 4 is negative 3. Okay, these root 5s are like terms. So 6 minus 7 is negative 1, but don't write the 1, just write negative root 5. And then this and this are like terms. So negative 2 plus 5 is a positive 3 root 6. Okay, the sum of the squares of the sides touching the right angle equals the square of the other side. So x squared plus 4 squared equals 8 squared. 64 minus 16 is 48. So x is equal to the square root of 48, which is 16 times 3. That's 48. But I can take out the 16 by square rooting and get a 4. So this is 4 root 3. On this problem, the sides touching the right angle are 5 and 10. So 5 squared plus 10 squared is equal to x squared. So x squared is 125. And 125 is 25 times 5. And I wrote it like that because 25 is a perfect square, which you can square root and it becomes a 5. So this is the 5 on the outside, root 5 that's left inside. Now you could use Pythagorean's distance formula on this problem, but because these coefficients are the same, the distance between these 2 points is negative 5 minus 2. Which is negative 7, but remember the distance is always expressed as a positive number, so this is positive 7. You could have used Pythagorean's theorem on this, but it wasn't necessary because these were the same. In this problem, we don't have a same formula, so we have to use Pythagorean's theorem. The square root of x2 minus x1 squared plus y2 minus y1 squared. So this is equal to the square root of x2, which is the x value of the second point, minus x1. So 2 minus a negative 4 squared plus y2 minus y1. This is y2, that's y1. Negative 2 minus 6 squared. Well, this 2 becomes a 2 plus 4, which is 6 squared. And this is a negative 8 squared. So this is the square root of 36 plus 64, which is the square root of 100, which is 10. Okay, we have a fractional exponent. The denominator is the index, so I'm going to square root 25 and get 5. And now I took care of this, so all we have is a 3 left. 5 cubed is 125. Here I have 3 things happening in the exponent. The first thing I'll do is the negative, which inverts this. So this becomes 27 over 8, but now it's to the positive 2/3. We just got rid of that. Now we have positive 2/3. Now I'll do the bottom, which is the cube root. Cube root of 27, the cube root of 8. Cube root of 27 is 3, cube root of 8 is 2. And finally, we have that exponent left. Square 3 and square 2, and you get 9 over 4. Okay, we have 3 things happening in the exponent. The first thing I'll do is the negative, which inverts this. So we have a positive 4 over 9, but now it's to the 3 over 2. Then I'll do the index, the bottom, by square rooting both of these. Square root of this is 2, square root of that is 3. And now that we took care of this, we just have the exponent left. 2 cubed is 8, 3 cubed is 27. Okay, to solve for x, I want to isolate this term, so I'm going to move that over to the other side and it'll flip signs. So I have 5x is equal to a positive 3y plus 7z. And you could have put that in the other order, 7z plus 3y would have been fine. And then we're going to divide each side by 5. So x is equal to 3y plus 7z over 5. When you have a single fraction is equal to another single fraction, you can cross multiply. So when I multiply this way, I get 6x. When I multiply this way, I get 10ab. Then I'm going to divide each side by 6. But this is a simplifiable fraction. 2 goes into this 3 times and into this 5 times. So my final answer is 5ab over 3. Okay, the LCD is the product of all of these. So the LCD is x, y, z. So if I take that x, y, z and I multiply by this first thing, and then I take the x, y, z and I multiply by this second thing, and then I take that x, y, z and I multiply by this third thing. And then I cancel. These x's cancel, the y's cancel, and those z's cancel. So you end up with 4yz minus 3xz equals 2xy. I got rid of the fractions. Now I want to combine like terms, or isolate by bringing this over. So I'll move this to this side. And I have 4yz is equal to 2xy plus 3xz. The x is showing up in multiple terms, so we isolate it by factoring it out. And our final step is to divide. We'll divide each side by 2y plus 3z. And this cancels, and we're left with x is equal to 4yz over 2y plus 3z. For number 65, I'm going to multiply each side by 3 to get rid of this fraction. When I multiply this side by 3, we get 12a. When I multiply the right side by 3, the 3's cancel, and we get this. Then I'm going to move this over to the left to isolate the x, and it's going to flip signs. So we'll have x is equal to 12a plus 2y. And that's it. Okay, for this, the only denominators are 4 and 3, so the LCD is 12. If I take that 12 and I multiply by this first fraction, and then I have minus, I'll take that 12 and I'll multiply by that second number, and then I'll take that 12 and I'll multiply by the third thing. Then I'll cancel. 4 goes into 12 3 times, and when I multiply this, I get 9x. Nothing cancels here, but we multiply. And in this, 3 goes into 12 4 times, so I multiply and I get 4. Now I'll move this over, and I'll get 9x is equal to 4 plus 24 is 28, and then I'll divide by 9. So x is equal to 28 over 9. Okay, in order to get rid of this fraction, I'll multiply each side by 5b. When I multiply this side by 5b, I get 10by, and when I multiply this side by 5b, those cancel, and we get 2x minus 4a. So to isolate this term, I'm going to move this term across, and it's going to flip signs. So the left side will be 10by plus 4a is equal to 2x. Finally, we'll solve by dividing by 2. But I can't leave this fraction the way it is because I have 3 terms, 1, 2, 3, and they're all divisible by 2. So I have to cancel out the 2. So my final answer is 5by plus 2a. Okay, we have to define the variable. And in this question, the question is asking how long would it take them to grade the test if they work together. So x is the time together. That's defining the variable. And the equation is you put the individual stuff on one side, the together on the other side. John grades all the tests by himself in 8 hours. It's an individual effort. Chad grades them all in 6 hours by himself. That's an individual effort. The time together is a combined effort, so this goes by itself here. Now the LCD is 24x, but let's say you didn't want to think about that. You could just multiply all these together and get 48x. And I'll do it like that. The reason why is because now when I cancel, I just get the other number. So I don't have to think much. This goes in 6 times, this goes in 8 times, and these x's cancel. So this gives me 6x, this gives me 8x, and this is 48. So x is equal to 48 over 14, which is 24 over 7. So this is 2 3/7, and this was in hours. Oops, I meant 3 3/7. Because this goes into this 3 times. So this times this is 21 plus 3 is 24. So 3 3/7 hours. Okay, Leslie has an area of 96 square feet in her backyard, and she wants to make a rectangular garden. So let's draw the rectangular garden. She knows she wants the length to be 4 feet less than twice the width. We don't know the width, so we'll call that x. But the length is going to be 4 feet less than twice this. Twice that is 2x, and then 4 feet less. And she knows that the area should be 96, because that's how much area she has. Well, a rectangle area is length times width. So x times 2x minus 4 must be equal to 96. I'll distribute this x, and I'll get 2x squared minus 4x, and then I'm going to bring this over in one step. So this becomes minus 96 equals 0. I'll factor out the 2. So this is going to be x minus 8, x plus 6 equals 0. This does not contribute to the solution. This gives us a positive 8. This gives us a negative 6. But when we think about a physical dimension, it could be as small as 0, nothing, but it can't be negative. It doesn't make any sense. So we throw this out. So now we have x is equal to 8, and now we know the width. To find the length, we do 2x minus 4. 2 times 8 is 16, minus 4 is 12. So the dimensions are and these are in feet. So 8 feet by 12 feet. Okay, so we have a rate times time equals distance problem. So I'm going to start there. Rate times time equals distance. And we have two people. We have Chad and Leslie. Now, it says that Chad drives 12 miles per hour faster than Leslie. So we don't know how fast Leslie goes, but Chad goes 12 miles per hour more than that. Chad goes 126 miles, so this is 126. And the same time that Leslie goes 90 miles, so Leslie's distance is 90. Well, if I'm given the outside two boxes, and I know that this times this is equal to this, we make a fraction here where this is the product divided by the other factor. Now when I multiply, these cancel and I get 126. So same thing here. It'll be 90 over x. The key to this problem is that it happens in the same amount of time. So my time values must be the same. So now I can cross multiply 126x equals 90 times x plus 12. And I'm just going to grab a calculator. 90 times 12 is 1080. And I'll bring the 90 over to the left by subtracting it. And 126 minus 90 is 36. And then I'll divide each side by 36. So 1080 divided by 36, I'm just using a calculator, I'll get x is equal to 30. The question is, how fast did Leslie go? And Leslie's rate is x, so we just found it. So Leslie goes 30 miles per hour. That's it.